We had and my descriptions about what we're doing this week are annoyingly vague, mainly because it's pretty much up in the air what we're doing this week. But of course, we unfortunately need to hold off on the exam um, until you get back. So I hate the fact that you do have to take your exam immediately upon your return to campus on next Monday, but that is when your next lab is, right? So those students would normally be taking their exam in lab 6 are now taking it in lab 7. There's just no other way to do it, and for it to be fair, other than making a extracurricular time that people may or may not be able to attend. So today I'm going to talk about I'll make sure I go into plenty of detail in about lab 7, so you can reference this again later, because a lot of you won't have lab 7 to work on this. So, and normally this is a lot more significant it feels like much more of a significant achievement after the after having taken this exam. All right, so let's go over lab 7, which is kind of our halfway point capstone. I know a lot of you are still working on lab 6 too, and that's fine. That's fine. Lab 6 is due at the end of the month. Lab 7 is, but again, I want to make sure you have this to reference if you decide to work over spring break. And to be clear, I expect you to work during spring break as much as I plan on working during spring break, which is not very much at all. Okay, so not if I can help it. So, we've got a message from a John Python. He says, hi, John Python. All right, so, all right. So there's a big scary text here. Don't worry about this quite yet, but our very apropos assignment is a hurricane tracker, where we are given a CSV file, which is a file that I will explain in a bit later, full of data on for us to read with the latitude, longitude, wind speed, and pressure of a hurricane. And your assignment is, when you finish your program for assignment 7, this is what your assignment will look like. It will display the path of the hurricane. You run it, and the path of the hurricane is displayed with the intensity, the category of the hurricane displayed this way. Now, you're probably thinking to yourself, geez, that seems very, very, very complex. Very, very complex. Well, let's take a bit of a closer look at this. So this is all deception. This over here, this hurricane symbol, is a turtle. And suddenly this assignment starts to make sense. This is a turtle. This is the turtle drawing. It's the path drawing. And it's using the go-to command to go to an XY coordinate. We've modified the XY coordinates to correspond to the latitude and longitude that I provide you. So you just tell it to go to a latitude, and it'll go to the appropriate XY coordinate. Make sense? So it's just a turtle. And you're going to be learning how to read a file. Sorry, and you got to read a file. So we're going to talk about file reading today. Okay? Which requires me to go on a bit of a tangent about files in general. First off, everything on your computer is a file, at least especially in the Unix philosophy, which means if you're using a Mac or Ubuntu. That means that everything is a file, including the folders. Those are also files. Your commands are also files. Everything is a file, okay? And thus can be accessed. Now, broadly speaking, we have 2 types of files, okay? 2 types of files. The first type of file is what we call a text file. Even though, and you're thinking like, oh, .txt files? Yes, that's what we include. but it's also things like HTML files, Python files, Java files, basically anything that we could reasonably read. For instance, let me open up Geany for a second. Here is a bit of Java code. Okay, this is Java. You don't need to be able to read Java. Okay, here is maze.java, which is a Java program for one of my, it's part of a Java program, a bigger Java program for one of my other classes, 2168. This is a text file because I can open it up in a text editor and it's meant to be read by a human. Even if it's not, completely 100% understandable, you can at least make, you could read the words of this file and look up what they mean and, try to figure it out from there. On the flip side, this compiles into maze.class, which my computer has just simply said it won't open it. It says over here, and it's hard to see down here, failed to load file, and then it gives me a path to that file. Data contains nulls or encoding is not supported. This is what we call binary file. So these are things like your executables, the .exes, the programs we run. But also things like .doc and .pdf files, right? You can't open those up in a text editor or, and you can't open up and see what's inside those things in the same way. They require a special program to read them. Binary files are meant to be read by programs on the computer. Okay, so those are two types of files. So we're going to be dealing with a number of, we're going to be dealing with a number of text files here as we go, as we work on stuff. Okay. So I know I'm being a terrible example here with what I'm about to say because I have all this stuff spread out on my desktop with all willy-nilly, but that's also because it's just stuff I don't care about for the most part, in the sense that I can delete it and I could get it again. I suppose I do care about this video. It's one of the otters at the Philadelphia Zoo. Three of the otters at the Philadelphia Zoo. Aren't they great? So, but also a binary file, video. It's meant to be read. The data in here cannot really be read by a human. Okay, but it's data. And it can be read, it can be modified, but we just need special programs to do that. Right? So let's go ahead and let's see, files. Right. I was talking about organization. Files basically have a path to them, right? In a lot of systems, we can right click on it, go to properties, okay, and you'll see its location. Like over here, I've got C drive, users, Profa, OneDrive, desktop, and that is just simply saying, hey, this is where it is on my computer. Windows computers, let's see for a second, stop share. Anything? Right? Yeah, we'll just use Notepad for a second. So let's go ahead and share again. All right. So Windows basically stores files like this. You have a C drive, C:/, and then you'll have something like users slash, actually, where was that file put? Where did I put that file? I believe it was user properties. Yeah, it was users. I'm just going to do slashes, even though Windows technically uses these slashes. Users dot username slash, and then maybe if it's in your documents folder, slash Python programs. Just call that Python stuff, and then .py. So your file name and path to the file on a Windows computer might look like this. Mac uses something different. And before I move on to that, let me just explain. The reason it's called the C drive is because you used to have an A and a B drive. You used to have an A and a B drive, but those are now were used for floppy disks, which have been lost to time. Essentially, we don't really use those floppy disks anymore to boot the A and B. So, and your hard drive was then C because that was for long-term storage. So yeah, old stuff. Anyway, Macs use Unix as their kind of use a Unix-based file system. So very similar to what you would use on a Linux. Their file system basically says the drives are abstract anyway, so we're going to start here, which is called what's called the root. So this is the top level domain of a Mac. The reason I'm bothering going over this is that a lot of the stuff you do on the Linux or Unix side can be internally interpreted by your program to basically correspond to what's going on Windows. And yeah, there's this whole thing for users, username, and whatnot. It has its own format, but essentially, the equivalent over here has a special symbol we can use on these systems. That symbol is the tilde, and that is essentially what's referred to as your home folder, meaning it's the stuff that belongs to whoever the current user is. It's useful. So the equivalent would be documents, and then Python stuff, and program.py. Now, why do I bother bringing this up? It's important for this assignment and for the next one. So for what we're about to do today in class, as well as your assignments, that you know where everything is. That's what we need to know. So when we go and download a file to mess with it, we know where it is. Now on idle, which is what the vast majority of you are using, okay, when we open a file, open recent, here's my slices, okay, it's again a bit hard to see here, but I'm gonna go ahead and draw on the screen. Everybody sees that, right? Slices.py. So it has the file name up here on top, but also right here, and where's is this? Let me go ahead and highlight. Over here, we have the file path, which tells us where we can find this file. When we're working with files, at least right now, for this class, it's important that the file you're trying to read and the program that's trying to read that live in the same folder, which at least for this file would be the desktop. So I'm going to go ahead and start by going to my folder over here. I'm going to go ahead and go to my file browser. So this would be Finder in Mac. I'm going to go over to where my documents folder are or is. And then I'm going to create a new folder called, like I was anticipating, Python stuff. And that might be or I could call it CIS 211051. I might not call it like that. Yeah, CIS 1051. And that'll be where I store all my and let's assume for a second that that's where I put all my Python stuff. Okay. In fact, why don't we go ahead and just shove some of the stuff that was there over there. So weird, for loop stuff, pig. So things that I haven't necessarily done. But anyway, like now it's a Python, and now it's full Python files. Great. Okay. So now I'm going to go ahead and I want to play around with file reading. File reading is actually fairly easy to do. But most of you don't necessarily know how to create a new file from scratch, and I don't want to have to walk you through this. And it's much more exciting if we just simply go for it. Okay. Just go straight in. So we're going to go to one of my favorite websites on the internet. Okay. So I'm going to begin here by saying this is my least favorite lecture to do because I'm going to have to stop and help students a lot here. That's not a problem. It just means that I can't go as fast. Not as fast, but like I have to take a lot of breaks, and I have to help a lot of people. If you're one of those people, don't feel bad because there's a lot of steps I'm about to do, and so it's easy to mess up, especially since I'm running on a Windows computer and you might be working on a Mac, or it might not even be your fault because you bought your computer in another country and that did weird things that I did not anticipate. Make sense? So just do your best to follow along. If you don't, no worries, and just be patient because I'm going to have to stop and help people along the way. So what we're going to do is that we are going to download a text file from a website called Project Gutenberg. Okay. The URL is gutenberg.org, Gutenberg, as in the Gutenberg Bible. You can also just find it by searching for Project Gutenberg. It is a very famous website, and just basically clicking the first link, gutenberg.org, brings us there. Project Gutenberg is a repository of as many public domain books and literature as possible. Public domain in the US, at least, which means that it's for things that where the copyright on these books have expired. The Most Dangerous Game, good one. Good one. So, yeah, rather than though, I don't know if it's gonna come up with that one for you, but why not? Let's go ahead and search for game over here. Let's see. Let's go with dangerous game. Dangerous game. Or if you saw it, you can go ahead and click on that one. Oh, it's not there. Interesting. Okay, I guess we'll have to skip that one. I'd rather it be easier to find. So let's just go with with good old Treasure Island. Let's go with Treasure Island. And we'll go and click on the first link over here. Treasure Island by Robert Louis Stevenson basically was the trope codifier to all the popular pirate tropes about thanks to Long John Silver and all other things. Now, this is a great website. You'll want to stay on this page by the way, right over here, this Treasure Island by Robert Louis Stevenson. And if you need to get there, I did choose an early book on purpose. If you are having trouble searching for it, you can go to gutenberg.org/ebooks/120 because it was the 120th file uploaded to this website. Now, there's a bunch, it has this in a bunch of binary files. It also has it so you can read this on the on the website itself. And they've got the original pictures in here too. But what we're interested in is the text file. Okay, we're interested in the text file, which if we go over here, there's all these options for formats. We're going to click on plain text UTF-8. Okay. Now from here is where the trouble begins. Okay. So we need to download this file, but there's no download button. So how do we do that? Couple ways. see, does save link as work here? Yes, that should. So a couple different ways. We could right click and don't be quick to just simply hit right click and download it, because this is where I said this is the part where we make mistakes. There's a couple different ways to do this. We can right click on it, save link as, or save file as, or however it's displayed in Macs. We can also open up this file in a new tab and then right click here and, well, save page as, might save it as a text file, or it might save it as an HTML file, depending on. In Windows, it will save it as a TXT file. So there's a couple different ways, but you want to save it as a TXT file. You don't want to save it as an HTML file. So that's number one. Number two, when we save this file, you're either going to want to save it in the folder that you're planning on writing a program in, or move it to the from downloads to that folder. So I'm going to do the first and the second. I'll show you how. Okay. So the first is I'm right clicking down and I download it and I hit save link as, and I go to my documents folder. I go to CIS 1051, which is where, and it doesn't have to be that folder. It can be anywhere you know you're going to be programming today. Okay. So I did documents, CIS 1051, and then I'm going to hit save, which will save a file called pg100.txt in my folder. The other way to do it is I'm going to right click on it, save link as, or in this case, I'll do it the other way. I'll hit save page as, and it says text file over here. And by default, it will want to go into my downloads folder, and I just hit save because I was kind of just, you know. In that case, if you've just dropped it in your downloads folder or anywhere where you're not going to be programming, then what you need to do is go to that folder, and I'm going to just press Control X or Command X on a Mac, go to and then navigate to the folder I want to put it in, and then Command V or Control V, depending on Mac or Windows, and then that will just copy it into here. Now, time for a mini rant, okay? Because I haven't been doing that already. Some of you, so you should see pg100.txt over here if you did it correctly. Except if you're running Windows, you won't see pg100.txt. You're going to see pg100. This is because Windows, in their infinite wisdom, the developers decided that it would be great to hide the file extensions by default, because most people don't need to see them. They rely on the icons more than the name. A file extension is the dot something that's part of a program, part of a file's name. It's not actually strictly required. You can always open up a program of something you know is a file of one kind in a program, and the file extensions don't have to match. That's why I don't try the whole trick of sending a picture renamed as a .doc file to a computer science professor. They'll be able to pick that up on that pretty quickly. Because it's still a picture, right? You can just open it in a file program. Okay. You just, by changing the name to .doc, you've just simply changed what by default it's going to open up in. So here, but I'm a programmer and I want to be able to see my file name extensions. So on Windows 11, hit View, scroll down to Show File Name Extensions. Ah, much better. Yes.
Go back to the first step.
Downloading it?
Yeah, I didn't catch it.
We just simply go over here to Project Gutenberg eBooks 120. You there?
Yeah.
Okay. Once we're there, we go over here to Plain Text UTF-8. This one over here. If you're on Windows, you can just simply right click and then save link as. And that will let you download it. Alternatively, you can go click on it and then right click on this entire page and go save page as. But I much prefer this way. It's more explicit. Then you just save it into the location you know you're going to be programming in. All right. That was the hard part. That was it, believe it or not. So the next thing I need to do is create a Python file to read the file. File reading is actually super duper easy to do. It is in fact what made me go, oh, this is a good language when I was learning Python. Okay, so I'm going to create a new file. I'm going to go ahead and save it. It's an empty file, but I'm going to go ahead and save it in my CIS 1051 folder, which is where I put the file. So wherever you put the file is where you want to create and save this file. Got it? So wherever you put pg100.txt is where you want to create this Python file. So I'm going to call this one file reading because that's what we're doing. .py. If you're on idle, right, same kind of deal. Idle, rather than saving, I'm going to, on idle, I would just create a new, new empty script, new file to pop this up and then hit save. You need to save this empty file somewhere, specifically wherever you're going to be programming. Not necessarily here, but wherever you put that file, wherever you put the file you downloaded. So documents, 1051, and then I'd save it in here. Okay. It's important that they're in the same folder, right? So that you could open up this folder and see, aha, here's PG100, and here's my file reading file that's currently empty. Make sense? It just got to be in the same place so that they know to look, so it knows, so this file knows to look what's here. By default, files will only look in the folder that it's currently in. Okay. You can mess around that, but it's much easier if we just simply put them in the same location. Finally, one last thing. If you're using VS Code, you may need to do the following. File. And then, right, you have this file open. What you'll need to do is hit open folder and then select the folder you're working in. And now on the side, you'll see all the files. Yes, I trust the authors because the authors are me. Now on the side over here, you're going to see, oh, there's pg100.txt, and here's the file I've created. Make sense? Because otherwise you won't be able to see, otherwise it's sandboxing it and it won't be able to see the file that it's working with unless you go through a few extra steps. All right, enough of that. So how do we open a file? It's ridiculously simple. And then the file name. pg100.txt. And you know what? I'll even make that shorter. Data is equal to this. Run, boom, boom. That's it. That's how you access a file. If this file does not exist, such as pg100.120, and I run this, I will get a file not found error. If you are getting a file not found error, that means you messed up in one of the previous steps. Make sense? Because it's got to look in the same directory. It basically says, open up in my current directory. In my current directory, that's what that means. By default, it just has that // in front. In my current directory, look for this file. Make sense? Okay, anybody stuck? Yes. What's going on? See? Right. It's normal that it's not going to do anything. No, it's oh, the file. Yeah. Nothing is good. Nothing just means there were no errors. Yeah. And this, we finally got two bodies where. Run it. What happened if you run it? No, it's just one error. No such file here. Run. $100.2. One there. Wow. This is- how are you? You did open this folder, right? Here. That should have been enough to do it. Go ahead and try to out that. Okay, not sure why that worked, but then we got. I don't know why VS does stuff. It's nonsense. Yes. Yep. Unless, is that what you named the file?
Yeah.
Okay, then that's good. Operation not permitted. So that's a different error. Why does it do this? Do not have permission to modify your own things. Seen this before, Matt. I don't get it. Matt's info. Conditions. Like this. I don't understand why not. Folder or whatnot. Or the title or whatnot. It's kind of a different program. I don't know why it's some students issues and why it without issues. You can also try a different folder than the document. Okay. It's supposed to do literally nothing. Right? Because all right. So oh sorry. You may need to allow Python to access the folder that you're in. That might be why that you're having issues. Okay. Now let's go ahead and let's see. Yep. I'll have to see it in person for that issue. But anyway, running it and just simply getting essentially nothing or getting just simply the like locations in idle, right? Essentially the program doing nothing is essentially what we want to see here. Okay. Mainly because the next step unless I'm mistaken, unless things are terrible, don't do this quite yet. In theory, this is how you read a file. This is it. I believe this just has a quick, yeah, I have to just do a quick thing for the Windows users over here. So when we open a file, there's Python's nice and it'll actually allows you to do it with a single argument. For the file we're getting from Project Gutenberg, because of the way it's formatted on Windows, we need to do one more thing, okay? Which is that after the name, we type the following, comma, encoding, I believe it's encoding, equals, it's either encode or encoding, but encoding is equal to UTF-8, which is a version of Unicode. That should run just fine. Yes. Okay. So we just add this bit in. You're never going to need this to do this bit again, except in this class. Sorry, except in this lecture for this specific file. Okay. It's just issues with Project Gutenberg files. Okay. And Windows. Okay. Now I will go through these methods in more succinctly, but I just want to test that. I just need to test that works for me. For line in data, print line. And there we go. There's a kind of fate in this, he observed when I had done. Every step, it's you that saves our lives. And do you suppose by any chance that we are going to let you use low ores? That'd be a poor return, my boy. You found out the plot. You found Ben Gunn, the best deed that you ever did or will do, though you live to 90. Oh, by Jupiter, and talking about Gunn. So this is a so it is that easy to read a file in Python. You just open it and you read. Okay, the encoding UTF-8 was just a thing we need to do because of the way Windows assumes things are encoded, or Python on Windows assumes things are encoded. So reading a file is actually pretty easy. This is the way you'll most likely do it for the assignment that you have for Lab 7. So what we do here is there's basically 3 ways we can read the file. This is the first way and kind of the way I found was really natural. And this is what made me fall in love with Python. It was like, there's no way this can work. And I literally just wrote this. There's like literally no way that me doing a for blank in the file will work. And it did. It worked well. It worked naturally. And what this does is that it will read every single line. I don't have to call it line. I could call it blah. But blah would then be essentially each line of the file and then printed it out. Not line. I said blah. I meant blah. And so it just prints out each. So sorry, the variable blah will then change to be line after line, which is why we have why it's double spaced, by the way, is because it reads the file, okay? It reads each line of this file, and each of these lines in the file has a new line character to tell it, hey, there's another line. So when we go and read the file, we read that new line character, and then we print it out with another new line character. So I can always do, I think strip should do fine. Do I need to do it like this? Does that work? Yes. So we can clean that up by doing blah.strip and print blah. I think I'll just go back to calling it line. That was just kind of show that we could name it line. So now, sorry, line is equal to line.strip. What strip does is that it takes away all the preceding and trailing white space of a string. So it makes it easier so it removes that extra white space that we have. And now we can print it out and it's much more in the way that's been rendered. So that's our first way to read this, which is that we go through every line using a for loop. There's two more techniques. The next one we're rarely going to use. We are literally going to use it for one problem this semester, possibly on the final exam. I say possibly because the way my final exam works is that you will get 7 questions and you choose 5. It is quite possible that you don't choose that question. That requires you to read a file like this, but it is super simple. Text is equal to data.read with parentheses. Very obvious as to what this does. Very, very obvious as to what this does. It reads the entire file into one megastring and stores it in text. Megastring is not an actual term. It's just, you understand now that it is a very big string. This is just a very, very big string that we are printing out. Print len of text. That's all this is. Text is now a string. It's a 383,000 length string. So it just simply takes the entire file and stores it in a string to do with what as you need. Typically, we want to be able to manipulate this a bit better than it just being in a string or in smaller chunks. So that's why typically what we'll do is that we'll go line by line like this, right? Make sense? So technique 1 was doing a for loop. So I'll put this over here. This is like our most common technique. Technique 1 says for line in the data, do this. And these quotes over here. So what this technically is what we call a multi-line string, which is a string that can span multiple lines. But if you do what I just did, which is that you do a multi-line string and don't actually assign it to anything, it effectively just comments out the code. So I will just go ahead and be clear, comment, comment, comment. So this is the first way to do it. The second way to do this is .read a file into single big string. Doesn't actually have to be a big string. Okay, and finally, the next way to do that is the advantage of this is that we do have this saved in a variable, right? This, we went by line, which is a more useful way to chunk this, okay? A much more useful way to separate out the contents of the document, but it does not lead itself to basically being useful because we aren't storing this. We're reading each line and then we're throwing it out, essentially. Or we're passing on. It doesn't, destroy anything on the file. Next, we do read lines, which addresses the issue that we're currently having. So it would be lines is equal to data dot read lines. And essentially this, the for, how we were doing a for loop to go line by line. Well, this gives us all the lines all at once, and it becomes a list of strings. Rather than one big string, it keeps them broken up. Print, and I'll just simply print lines, print length of lines. All these are legitimate ways to do this. It just depends on which you find easiest based on the circumstances. And so now I've printed this out and you can see it is a list, right? Here's a string, then here's another item in the string, then essentially an empty line, then another item in the string, then another, and so on and so forth. Make sense? It's just a big list. Go down to the bottom. big list, and we can see here the number of lines, the number of items in the string is 7,856 items, which if we check PG 120 and scroll all the way down, that's darn close to, that's like off by one of the number of lines we had here, like in the file. It just didn't get that last blank line because of just the way that last line is ended. That's fine. So reading a file is actually pretty dang easy. Okay. And I find that, it's very easy to kind of mess with these things once we're reading our lines. For instance, if I wanted to figure out how many times the word pirate occurred in the book, Treasure Island, I would open up the file like I've done. I would write a for loop for line in range, not range, but in data. Then what I'd like to do is that I could check if pirate is in that line, but that would just tell me how many lines it would occur. It's possible pirate occurs more than once a line. Okay. So what I'm going to do is I want to check every word. How do I do that? Well, if I think about it for a second, and I've actually thought about it for way too long, more than a second, over the years, well, every single string word, you can tell if it's been every single word, the way you tell one word ends and another begins is you use spaces. So if we split things up based off of spaces, then that's easy. So there's a technique we can do in Python for that. Line is equal to line, or I'll actually call this words. Words is equal to line dot split, and then I'm going to say space. And I'll go ahead and print the words just to kind of show you. I said I will print it, and now there we go, and we see that now. Let's zoom up. Okay, I believe the silly fellows must have thought they would break there, and again, there's the new line character I was talking about at the end of the line. So I have it separated out by spaces, and now I can check every word. For word in words. So I like to do it a lot of the times this way for singular in plural. If pirate, and I'll explain that in a second. If pirate if word equal, we'll do it like this. If word is equal to pirate, or word equal to pirates, I'll be plural, the plural. Make sense? Then I need to create a count, so I'll do that here. Count is equal to 0. And every time I see that word pirate or pirates, I'm going to say count is equal to count plus 1 to increment it. And at the end, print that count. Okay, let's go ahead and look at the full product. It's 10 lines total. And surprisingly, it says only 16. So I got to think of a reason because that seems low. Oh, wait, what about capitalization, right? So what I'm going to do over here is I'm going to add one more word, one more line. Word is equal to word dot lower to convert it to lowercase. I'll also remove this line over here because we don't need it anymore to print out all the words. We don't even need to print out words by words. We need to find a count. Oh, word is equal to word dot lower. says 0 now. Interesting. What did I do wrong? What did I remove? Did I do something wrong? Boop, 0. So, oh, right. I need to call the function. 16 still. So if word is equal to pirate or pirates, surprisingly, only 16 times. Let's go ahead and figure that out. Control F, pirate. Pirate. The old buccaneer, right? So there's a word that's like pirate, but is not. Pirate, 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 pirate. So pirates came ashore, pirate, pirates, 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 pirates. And then, yes, not that many. Search for all the pirates, found 23 matches in our document. So I'm not sure why we're not getting all the pirates in here. Could be some weird graphical stuff, but pirates doesn't actually occur all that much in a book about pirates. Interestingly enough. You'd expect it to appear more times. Oh, well. But that's just because our method of doing this is imperfect, I'm sure. 16. I do wonder which ones I am missing. So, yes. Oh, you're right. Commas and periods. I had thought about doing that. And I even thought about the way of getting around that, which was flipping this around. If pirate in word, which basically says, hey, is pirate a part of this word we're looking at? Because we also have all the punctuation in here too, right? So if the word sentence ended with pirate, it wouldn't have matched. Make sense? Whoops. And I just got to make sure not to hit 5 when I hit the run button. And now we're up to 23. Thank you very much. Okay. So doing this so as you can see, this is a powerful, powerful tool. Make sense? Powerful, powerful tool we have over here in reading files. Oh, and if you can read files, that means you can read basically any file. Yes, Excel files are a binary file, but believe you me, there are plenty of, there are libraries that allow you to open up Excel files and modify them and work with them in Python. Suddenly, if messing with Excel gives you headaches, right? But messing with Python gives you less of a headache, there's a way around that for you. Okay. Web pages are files, although you can't really use the open command to get them directly. The first thing you have to do is use an internet command to download, a Python command to download that page off the internet, and then you can open it up in your, just like this. Being able to open files like this is a powerful tool. For those of you looking for a challenge over spring break, because like you have so much time to do stuff, okay, I can leave you with a puzzle because there is nothing stopping you from opening another Python file or opening yourself, right? For those of you operating over spring break, I want to leave you with a type of program, and there's different rules for it, but it's a program called a Queen or Quine. I don't know how it's pronounced, but basically it's a program that when run prints its own source code as its output, right? So it prints itself as its output, which is a bit of a puzzle to figure out how to do. Especially if you add the restriction and know you cannot read or write files, but that's its own kind of difficulty. So now you've got this. Let's go ahead and take a look at the homework in the last 20 minutes of this. So our homework for lab 7, which isn't due for a while, but I figured I'd talk about that since the entire thrust of this was towards this. Let's go to assignments. Wait. And this is under module 7 as well, Hurricane Tracker. So we have big scary text here. So first, download the starterfiles.zip and unzip in the directory of choice. I'm going to go and put this into my coding folder, which is CAS 1051. I'm going to save this. Okay. This next line over here, unzip in the directory of your choice. I'm saying this very pedantically because I had this a couple times last year where students, they would double click on this. It's a zip file and they would open it up and try to work inside of it. It's a zip file. A zip file basically is a compressed file. It's a way of combining multiple files into one file, into kind of one basically packed up file. So this is useful because now when I have, the reason for this is, well, as you can just see, I need you to download a whole lot of files, and rather than making you download them individually, I can make you download them all at once with the correct file structure. Okay. So there's different ways to open this zip file, but you don't want to go in here and then start modifying things inside this folder. Like while you're inside the zip file, see how I'm inside starter.zip. No, what you need to do is unzip the file. You can do this with extract all over here, or when we were over here, we could just copy, we could have just, physically moved this and drag and dropped, because modern operating systems are awesome like that. But generally speaking, when you extract a file, you do something like extract all or unzip or whatnot, or if you're like me and you use 7-zip, although I apparently don't have them installed here, you can do that. So right click, extract all, you'll get a dialog asking where you want it, and just hit extract. It will extract by default into the folder here. I have a starter files inside of my starter files, so I'm just gonna, that's fine. I'm just gonna do this. Okay. Starter files. Starter files contains 3 files in it, 2 of which are folders, and 1 is a Python file. If you're operating in VS Code, you want to open up this folder to work with. If you're like me and you're going to be working in idle, which is what I'll do, I will open this up with idle. So I'm going to open idle. I'm going to navigate to where that is. Go to open, documents, wherever you saved it. If that's in your documents folder, great. Navigate to starter files. Do not navigate to the starterfiles.zip. It shouldn't even appear as an option for you because it's not a Python program. If you try doing that, you're going to have a bad time. So go into the starter files folder. If you're not seeing this, you didn't unzip it, or you're in the wrong place. Starter files. And then I'm going to open up irma.py. This is the only thing I really need to open with this. And it has code that we can run. Don't worry. You'll notice that it flickered there. That's fine. That's just a aspect of the rendering library having changed over the years to do things. So let's go ahead, and I'm just going to go over here and do, I think it's turtle.done for a second. And there. And that will make it. And so you can see that we've got basically a blank program going on over here. Okay. And if we open up our screen, hey, look, there's the turtle over there. You might be wondering where it is, why it's all off the screen. This is basically the bit of the world that we have a snapshot of. And the turtle always starts facing east at location 0, 0, right? What we've done, and I'll show you in a second, is that we've run some code that defines basically this XY latitude, longitude. And so this would be latitude, longitude 0, 0 over here. But that way, if I tell it to move to a specific latitude and longitude, it will. So let's look at the code first before we discuss this anymore. The code has def Irma setup. And it has a nice big warning in here saying, do not change the code in this function. Got that? Nobody, you don't want to change the stuff in def Irma setup. Creates the, and we can read what the documentation, the notes, the comments that the user has left for us over here. Creates the turtle and the screen with the map background and coordinate system set to match the latitude and longitude. Return a tuple, which is like a list, containing the turtle and the screen. We don't really need the screen, but they return it. So here, what does this do? It imports tkinter, which is a library it's a library that Turtle is built with. It's the Python graphics library. It does setup, which sets up the size of the window. It gets that window, it calls it Hurricane Irma. And then what it does is this creates the background. And it sets up the coordinate system for our background to match up to latitude and longitude, defining the bottom left corner as -90, 0, and the top right corner as -1766.45 in latitude, longitude. Or is it longitude, latitude? What is longitude and latitude? Those are coordinates, but which is which? Which one's X and which was Y? I asked this because I spent 3 hours because I like to do these programs before I give them to students. And I spent 3 hours maybe trying to figure out what the hell I had done wrong. And the answer was I mixed up latitude and longitude. So instead of going to XY, I was making my turtle travel to YX. And that's why it wasn't showing up. So if your turtle is not showing up on your screen due to what we're doing and how we're making it move, maybe you've got your X and Y's mixed up. Make sense? So hopefully you can learn from that mistake and not spend nearly as much time as I did. So does all this stuff to set the background image and then set up the turtle. And then it gives us a turtle, a window, and a math background image. We don't need actually anything. All we need is T. T is our turtle as opposed to Bob. He's our Bob. And now that he exists, why don't we go ahead and test that this works by making him go to Disney World? Okay. Disney World needs another hurricane, right? Where is Disney World anyway? Disney World. That long for latitude, longitude. Isn't Google great? It tells me that Disney World is at 28.3772 north and 81.5707 degrees west. So that's where we should make our turtle go. Latitude, longitude. Now, what's important is that to note is that the latitude is presented first, then the longitude. The measurement of the degrees north to south. These are the latitudes. And the longitudes go the other way. Right? Here's our latitudes. The longitudes go this way. So our latitude explains how high we are, how much north or how much south, which is our Y direction. So even though we say latitude, longitude, this should be our, even though this one comes first, because latitude, longitude, we should make this our second coordinate. So how do we get them to move? Well, what we're going to use is we're going to use a new turtle function that you probably haven't used called t.goTo, which goes to a specific XY coordinate. So the Y coordinate we'd like this guy to go to is 28.37.72. And our X coordinate is 81.5707 west, which means we want to go here. But we said 81.5707. Why did you put negative? Because it's west. as opposed to east. West is negative numbers. East is positive numbers. North is positive numbers. South is negative numbers, at least in this. And now we run this. And we see, yep, longitude is the X. And we see over here that it followed our commands and it went to the appropriate latitude and longitude. And that seems to correspond close enough to Disney, right? Mm-hmm. You know, I'm sure I'll hear from the Mouse's lawyers any day now for sending hurricanes to Cinderella's castle. So they haven't caught on to it yet. So now the question is, now that we've got this, so we've got a go-to. So as long as we're provided with lists of coordinates, we can just tell the turtle to go to places. Okay, so we need to read a file to do that. Do we have that file? Yes, we do. We have a file. In fact, we have lots of files. First off, we have images. And this is kind of where I'm going to take your hand and pull you along here. Atlantic Basin .png and hurricane.gif. There's not really any point in me posting any of this code. You can just refer back to this video recording because you've got this code. You have it all. And you got to get it set up on your computer by yourself to make sure that's working. Okay. Because let me back up a second. Okay. Blah, blah, blah. You cannot modify it. It is essential all work is done in the irma.py file and the file structure present in the zip file. Notice that this is all giant text over here. The file structure present in the zip file is maintained so that irma.py can find all other files. If you do not know what this means, ask your TA, your professor, or your classmates. Demoing this assignment and getting an error due to a misplaced file will result in an instant zero with no appeal. As it means you did not write your own code and did not learn how files work. Simply put, the reason this clause is there is because I often would get people who had obviously gotten their irma.py from their friend, downloaded it, and then like any other Python file, and then proceeded to try to run it, and then would not be able to answer why their file was not working. Because the only way you can run it is if it's in this file structure. Otherwise, it's not going to find the backgrounds and the files, right? It's got to be in this structure. Don't worry. So you're allowed to come to me to ask me to help you figure this out. You're allowed to say, hey, how do I set the file structure? Hey, how do I make sure I'm reading this file? It's just when you say, yeah, I'm done with the file. I want my grade now. You know, that you want to at least test it, right? Okay. Anyway, that's there just because it's my easiest way of getting out of dealing with the fact that that somebody cheated, not you, but somebody cheated on this assignment, and then not going through and not having to go through this entire. Well, you can't prove that I did cheat, and yes, technically that's right, but it's impossible for you to have done this so poorly, right? Unless you. In gotten this error unless you did. And I don't think I can convince a bunch of non-programmers. Okay. So the important bit here is that we have these images here. They're stored in images and then Atlantic Basin.png, hurricane.gif. Okay. And you'll notice how they get assigned. Let's go ahead and notice how they get assigned. In IRMA, they get assigned by this. So they it figures out the photo for the Atlantic Basin, which is the background. And it doesn't say Atlantic Basin.png. It says images / Atlantic Basin.png. So that's how you interact with folders. You say the folder you want to go to / the file. And this is understood to be a folder in the same folder as irma.py is. It's understood to be a folder inside here. Okay, so images slash. You do not want to do this slash, blah, 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 especially on a Mac, because remember, this is the top level domain. So it's looking at the very tippy top of your computer now for a folder called images, which is not going to be there, right? So this assumes, hey, images is, oh, I'm in the same folder, look for that same folder, look for this file. Oh, there's a images slash hurricane GIF. So I'm going to look in the images folder for hurricane.gif. Make sense? So where do you get all the data and where do you read it? Well, there's a folder called data, and inside of data is a bunch of files with names, because we give our hurricane names, because, you know, it's better than calling them like Hurricane 12, you know, something like that. So Hurricane Irma, we have a CSV file. Now, naturally, if you kind of just naturally go and double click a CSV file, it will open up in a spreadsheet program of your choice. Okay. This is because it's a program that's understood to be this is a program that is understood because it lends itself nicely for doing tables. This is what a CSV file looks like in a more human readable format. It's a table. And inside it has the date and the time. And then, oh, there's data we need, the latitude and longitude, and they're sequential, right? So I just read this line, then do this line, then do this line, then do this line, and so on and so forth. Make sense? And then you have wind speed and pressure, which the wind speed will help with figuring out what category it is. Okay. If you open it up like this in Excel, it will come up with all this data. So we can read this by going to data/irma.csv. That's how you open this file. You don't say open irma.csv. You say open data/irma.csv. Okay. Now, alternatively, you can also open this in a text editor. Let's go ahead and, so here's, watch this, open data. There's nothing in there because it's looking for Python files. I'm going to select, not text files, but all files. And I mentioned CSV files are human readable files. Even though you can open them up in Excel, you can read them in there. So no, you're using a for loop to automatically read the latitude and longitude and move them. So you're not going to be copying in these things manually by hand. The way this should work is that if I so asked you, I could ask you to change what file you're reading and it would work. Okay. So Irma, so focus on reading this file first and foremost, then focus on figuring out how to move that turtle. So irma.csv, if I open this here, we notice that this is what it looks like. This is what the Excel file turned into a table. We see date, comma, time, comma, lat, comma, long, comma, wind, comma, pressure. CSV stands for comma separated values. It is a table that can be read by a human or by a program. It's why, and basically any file can be exported from Excel as a CSV file, but you might lose it, but you aren't going to be able to get those pretty pictures because those can't be rendered as text. So this is useful for exporting your data to be used in another program. But here we see comma, we see August 30th, 1500 GMT as the time. Here's another field, here's another field. Now, how do you make sure you access these individually? After all, each of these has a different number of characters in each field. Well, we kind of learned that earlier, just we weren't paying attention to that. We can take a line and we can split it up by something. If I wanted to turn a string, here, I'll just kind of show you. Take this line, Gonna go ahead and put it in idle. Python shell. Dot. So I'm going to turn this into just a, let's call it line, because that's what it's going to be in your variable. Blah, blah, blah. It's that. Line dot split isn't going to do anything. It's going to say, whoops. Give me a second. Line dot split won't actually do it. We'll separate it by spaces automatically. But spaces ain't how we want to separate this. We want to separate the comma separated value file by commas. Right, kind of in the name. So notice what happens when I do this instead. Separate, I tell it to split it up by commas. Suddenly it becomes a list of, this turns into a list of strings that has been separated by commas. And I can access them now individually. You have plenty of time to do this assignment. Don't worry if you're not there yet. I just figured I'd give you all the tools in case things go horribly wrong for Thursday. That was fun. I accidentally hit the height thing and just kind of sat down. I was talking. That was interesting. It should all just be one loop. This is all going to happen in one loop. Unless you program it incorrectly. So, okay. With that, I wish you a good day and stay warm and safe. Sorry, what's up?
It doesn't want to pop up.
We're going to pop up.
It just
Oh, let's see. No file that, so file, open folder. This one we definitely need folder, starter files. Select. Otherwise, it's not going to be. I think you got to do it like this. Otherwise, it's just not going to find the files. This should work. Yeah. Yeah. Otherwise, it just doesn't want to find it.
I just clicked the folder nonstop.
Yeah. You just got to go to open folder in VS Code. One second. Yes, this meeting was recorded, and I'll upload this to YouTube, YouTube like all the other recordings.
Yeah, so I'm in the Monday now, so I haven't done the exam yet. And for personal reasons, I have to come back from home on a Monday, so I'll be here at like 9 p.m.
All right.
After school. So when can I do the exam since I'll miss? Like,
When would you prefer?
I don't.
Would you prefer to take it beforehand? Would you prefer like before spring break? Would you prefer to take it after spring break?
I don't like to be in before spring break.
Okay, just send an email to your TA and coordinate. Yep. Super easy to deal with because you told me in advance.
Yeah, that I just wanted to.
Need to demo my thing.
Which one?
I think this is that 4 or 5.
Don't worry about it. I've got to make sure I have time today, but you've got time. Don't worry about it. Okay.
Yeah, I can't do this at like spring break. So
You
I
can.
have to demo it like
You can demo it during spring break.
I know the teachers will be all out. I know like the teachers will be out.
I mean, I'll be on Zoom. You can demo it to me over Zoom. If you need to demo things with me, I'm more than happy to demo them to like tomorrow over Zoom. Okay, just send me an email and we'll coordinate a time. Yes.
Quick question. So I'm in the Monday early one.
Yep.
Lab, and since we're taking the test after break, and the Hurricanes due that Thursday, do we have like? Does my lab class get the next